Welcome to Sleepy Stories. In this episode, we will take a clear and steady look at why space feels so vast, and why the universe can seem far larger than anything the human mind was built to handle. This story is here to help you rest while you learn, to give your thoughts a slow and gentle path to follow as your body unwinds. If you do not fall asleep right away, that is completely fine. You can still let your mind wander through calm, interesting scientific ideas before sleep arrives in its own time. Simply listen, let your breathing slow, and allow the information to settle at its own pace. Before we rise into the universe, we begin with something small and familiar. Imagine the room around you. Even with your eyes closed, you have a clear sense of its size. You could walk from one wall to another without much thought. The ceiling has a height that feels comfortable. Furniture, doorway, and floor all fit naturally into a scale your mind has learned since childhood. While you listen, if these quiet explorations help you, you are welcome to follow more episodes of Sleepy Stories, or to like and subscribe so they are easy to find again. Now picture stepping outside at night. You move through a hallway or across a small garden, and none of these distances trouble you. As long as you stay close to buildings, trees, and familiar objects, you can still estimate how far things are. Without needing to calculate how long it would take to walk from one point to another. Your brain has spent a lifetime measuring and comparing. Then you look up. The outlines of roofs and branches end, and above them is a dark surface that does not seem to have an edge. A few bright stars appear first, then more as your eyes adjust. Each point of light is tiny. The sky gives you almost no clues about distance. There are no overlapping shapes, no shifting shadows, no clear sense that one star is closer than another. Everything seems to exist on a single flat surface overhead. Your senses try to treat the sky as if it were the ceiling of a much larger room. They reach for the same rules that work indoors or on a familiar street, and they fail. You cannot tell whether a star is as far as a hill, as far as a cloud, or far beyond anything you have ever walked across. Without clear information, the brain stops trying to assign a precise distance and instead creates a different category. It gathers all of those lights into a single impression, a background that feels extremely far away but has no specific number attached to it. This is the first step toward the feeling that space is vast. The universe has already moved outside the range where your everyday sense of scale works. In your room or on your street, you can picture yourself crossing the distance, reaching the other side, touching the wall or the tree. Under the night sky, you cannot picture yourself walking to a star. The path is missing, and with it, the feeling that the distance is manageable. Instead, you stand still, and the sky seems to stretch without limit. As you lie here now, you do not need to solve that puzzle. It is enough to notice how different the sky feels from the room. One belongs to your body and its memories of walking. The other belongs to a universe far larger than those memories. Between them is a quiet gap where thoughts can slow down. You are held by a familiar space while your mind looks outward into a much larger one. In that contrast, the story of why space feels so vast begins to unfold. Your senses begin at the scale of your own body. Without needing to think about it, you know how far your arm can reach, how many steps it takes to cross a small room, how your weight shifts when you lean forward or turn around. Your eyes, muscles, and inner sense of balance work together to keep a constant, quiet record of these distances. Every day you reinforce this map, walking through doorways, climbing stairs, sitting down and standing up again. The world feels understandable because it usually stays within this familiar range. When you look down a hallway or along a street, your depth perception gives you clear cues. Objects that are closer appear larger and show more detail. Surfaces with texture, like bricks or tiles, seem to shrink as they extend into the distance. Moving your head slightly makes nearer things shift more than distant ones. These small differences are what your brain uses to decide how far away something is. You have been using these rules since childhood, so the process feels effortless. Even outdoors, where distances are larger, the same principles still apply. A tree nearby looks bigger than a tree far away. A hill on the horizon appears small, but your mind knows it is large because you have seen hills up close before. Clouds move against the sky, giving you a sense of depth between them and the ground. Light scatters through the atmosphere in a way your eyes are tuned to interpret. All of this keeps your inner map of the world anchored to scales that you can walk, climb, or drive across. Your senses evolved for this environment. They are tuned for ground you can stand on, objects you can touch, and distances you can cross within a reasonable time. Your eyes can resolve features that are useful for survival, such as the movement of a person at the other end of a field, or the outline of a tree in low light. Your muscles and lungs are suited to journeys measured in minutes or hours, not in years. The rhythms of your body set a natural scale for what feels normal. When you look at the night sky, most of these cues disappear at once. The stars do not grow smaller as they recede into the distance in front of you, because their apparent sizes are already too tiny for your eyes to resolve as anything other than points. There is no visible texture stretching away from you, no reference line like a road or a row of houses to show how distance increases. Moving your head does almost nothing to change their positions, so parallax, which helps so much at ground level, becomes useless. Because of this, your brain cannot apply its usual rules. It tries for a moment, searching for familiar patterns, and then quietly gives up. The stars are placed into a different mental category, one that might as well be labeled far beyond reach. They all share that label, whether they are relatively close neighbors of the sun or distant giants across the galaxy. To your senses, they are simply very far, with no meaningful distinction between them. Numbers behave in a similar way. You can easily picture 2 meters or even 100 meters, because you can imagine walking that distance. A kilometer may take more effort, but you can still relate it to a known experience, such as the length of a familiar route. When distances reach thousands, millions, or billions of kilometers, they no longer fit into that frame. The words remain, but they do not attach to a clear image. Your mind compresses them into a single sense of magnitude, something like extremely large, without the fine detail. This is not a flaw. It is simply a sign that your senses and brain are optimized for a different environment than interplanetary or interstellar space. You carry within you a map scaled to houses, streets, and landscapes, and you use that map with great skill. Space feels vast in part because that map has to stretch far beyond its intended range. When it reaches its limit, it does not break. It just becomes quieter, replacing precise pictures with a broad, hazy feeling of enormity. A feeling that will follow you as the story continues to move farther outward. Before you think about the wider universe, it can help to stay close to home and look at the space around Earth. Our planet is large by human standards, yet in cosmic terms it is modest, one world among many. Imagine a ball of rock and water with a thin film of air wrapped around it. Almost everything you have ever seen has taken place within a narrow layer near the surface of this ball, a layer only a few tens of kilometers thick compared with a planet more than 6,000 kilometers across. You live inside a shell very close to the ground of a single world. Above this shell, the air gradually thins until it becomes too sparse to breathe, and then too sparse to scatter much light. There is no sharp edge that you could see from the ground, only a slow fading from blue sky to dark. Our atmosphere feels endless when you look up, but from the outside it would seem delicate and limited. Photographs taken from orbit show a bright curve of Earth edged with a thin, glowing line. That narrow band is where almost all weather, wind, and life are concentrated. Beyond it, the space around our planet quickly becomes more empty than any desert on the surface. The moon moves through this emptiness. When you see it in the sky, it appears as a round disk, cycling through phases. It is natural to imagine it as just beyond the clouds, yet its true distance is far greater. If Earth were the size of a small globe you could hold in your hands, the moon would be a smaller ball set far away across the room. The real gap is about 380,000 kilometers, a stretch so large that light itself takes just over 1 second to cross it. Spacecraft need days to travel that path. Between the two bodies there is no bridge, no air, only a wide reach of almost perfect vacuum. This distance is still tiny compared with the reach of our local star. The Sun dominates the solar system, a sphere of hot plasma so large that more than 100 Earths could fit across its diameter. Yet from the ground it appears as a small circle in the sky, about the size of a coin held at arm's length. The gap between Earth and Sun is about 150 million kilometers. Light covers it in roughly 8 minutes, which means every time you feel sunlight on your skin, you are feeling energy that left the Sun a short time earlier. This is the scale of our cosmic backyard. Astronomers use these nearby distances as training steps. They measure the time it takes for signals to bounce off planets, track the orbits of the Moon and artificial satellites, and compare those motions with the pull of Earth's gravity. From these measurements they derive sizes and separations with increasing accuracy. Terms like Earth radius, lunar distance, and astronomical unit become tools to describe positions in space without always repeating long strings of digits. For someone outside astronomy, these units may seem abstract, yet they are rooted in paths, followed by objects we can see. When you think of Earth, Moon, and Sun in this way, you begin to feel that even the closest layers of space are far larger than anything you can cross on foot, yet they are still small compared with what lies beyond. They form a first rung on a ladder of scale. The planet you live on, the satellite that circles it, and the star that warms them both occupy a region that is familiar enough to name and measure, but already too wide to picture as a place you might walk across. From here, when you look upward at the night sky, you are not seeing a flat ceiling. You are looking out from a defined neighborhood in space, into distances where your intuition has only just begun to stretch. To understand why space feels so vast, it helps to look at the solar system as a kind of test for imagination. On paper, it sounds simple. A star in the middle, planets in orbit, smaller objects sprinkled throughout. The structure seems clear enough. Yet when you start to think about the actual sizes and distances, your intuition begins to slip. The planets are tiny compared with their orbits. The orbits are huge compared with the planets. Most of everything between them is empty. Imagine shrinking the Sun to the size of a large, glowing sphere, perhaps as big as a common doorway. If you place this model Sun at one end of a long field, where would Earth go? In a realistic scale model, Earth would be a small bead far down the grass, not close at all to the surface of the Sun. The Moon would be even smaller, circling that bead at a distance that is still broad enough to place a few more beads between them. The other planets would be tiny dots scattered at increasing intervals, each one separated by long stretches of bare field with nothing in between. If you tried to walk this model solar system, you would spend most of your time passing through empty space. After leaving the model of Earth, you would cross a long gap before reaching Mars, and then greater gaps before reaching the belt of small rocky bodies between Mars and Jupiter. The model of Jupiter would be larger than Earth, yet still small compared with the space around it. Beyond that, Saturn, Uranus, and Neptune would be spread out at distances that would test your patience. The edge of this system would not be a tidy circle, but a fading region where small, icy bodies trace long, slow paths around the central star. Real spacecraft confirm this sense of distance. Even traveling at high speeds, they take months to reach nearby planets and years to reach the outer regions. Once they pass beyond Earth's orbit, their journeys are measured not in short trips but in long, careful arcs through a quiet environment. Signals sent from Earth take longer and longer to arrive. The light they see from the Sun grows weaker, spreading over broader areas as they move outward. There are no rest stops, no landmarks, no clouds or hills, just a steady drift through space that changes very slowly. When you look at diagrams of the solar system, it is easy to forget these proportions. For convenience, many drawings place the planets close together and enlarge them far beyond their real relative sizes. This makes the system easier to see on a page, but it hides how much nothing there really is between the worlds. In reality, each planet is like a small island in an enormous dark ocean, and the light of the Sun is like a distant lighthouse whose beam gradually fades with distance. This arrangement is not an accident. Gravity bound the Sun and its planets together, but it also allowed smaller particles to be swept up or scattered away over time. Collisions, close encounters, and the gentle pull of the star organized the system into stable orbits where large bodies are widely spaced. Too many large objects close together would have torn the system apart. The emptiness you see between planets is part of what makes the whole structure long-lasting and relatively calm on human timescales. When you hold these ideas in mind, the solar system stops being just a list of names and becomes a volume you can try to picture. Even so, the mind quickly reaches the edge of its comfort. Distances that spacecraft spend years crossing have no direct match in your daily life. Journeys that seem straightforward in a drawing turn out to be long, lonely paths through nearly pure vacuum. The result is a quiet realization. If this single system around one star already stretches your imagination, then the spaces between stars, and later between galaxies, will stretch it far more. The feeling that space is vast is already present here, in the long, mostly empty reaches that lie between the familiar worlds of our own star. Between the worlds of the solar system, there is a kind of silence that is hard to compare with anything on Earth. Imagine leaving the orbit of Earth in a small, well-protected spacecraft. The blue of the planet shrinks behind you. Soon it is a round disk, then a smaller circle, then a pale shape against the dark. The familiar glow of air and weather fades away. Ahead of you there is no visible surface, no road, and no nearby object to judge distance. There is only a deep background of darkness, with a distant sun shining at the center of everything. In this environment there is no air to carry sound. Engines that fire do so into almost perfect vacuum. Their vibrations stay within the structure of the spacecraft itself. If you could somehow float outside, safely shielded from the radiation and cold, you would hear nothing. There would be no wind, no rustle of leaves, no distant traffic. Even the concept of weather disappears. Temperature is not set by moving air, but by how much sunlight reaches you and how quickly your craft can radiate heat away into space. The distance between planets is often described in kilometers, but those numbers remain abstract until you think in terms of time. A spacecraft uses long arcs rather than straight lines, curving through space under the combined pull of the sun and the planet it is heading toward. Days pass, then weeks, sometimes months, with almost no change in what can be seen out of a window. Stars keep their positions. The sun grows slightly smaller and dimmer, or slightly larger and brighter, but the change is slow. The feeling is not like crossing a crowded sea. It is more like sliding quietly through a dark, nearly featureless gulf. Scattered through this gulf are tiny grains of dust and larger fragments of rock and ice, but they are sparse. The average distance between significant objects is enormous. A small asteroid may travel for ages without coming close to anything else. Streams of charged particles from the sun, known as the solar wind, flow outward, but they are so diffuse that they pass unnoticed by human senses. Only instruments that count particles and measure magnetic fields reveal that this emptiness is not truly empty. Light from the sun extends in all directions, spreading out as it goes. Close to Earth, it is bright enough to cast strong shadows and warm the surface. Farther away, it weakens and softens. At the distance of Jupiter, sunlight is not just dimmer, it is spread thinly over a much larger sphere, turning day into a pale, distant glow. This gradual fading adds to the impression that you are moving away from the center of warmth and into a vast, quiet region where changes happen slowly and gently. When diagrams show the solar system, the gaps between orbits are usually compressed to fit the page. The planets appear lined up, each with a neat ring around the sun. In reality, those rings enclose enormous volumes, and the planets themselves occupy only tiny parts of them. Between one orbit and the next lies a three-dimensional shell of space that a spacecraft can travel through for a very long time without ever passing close to a planet. The emptiness is not a thin line. It is a broad, deep layer. For a mind used to landscapes, this kind of environment is unfamiliar. On Earth, empty places still have features. A desert has dunes and rocks. An open ocean has waves and weather. Even a quiet plain has grass, soil, and the distant outline of hills. In interplanetary space, there are no such supports for scale. Distance becomes something you infer from calculations and the slow change of positions on instrument panels. The feeling that space is vast grows naturally from this. It is not only that the gaps between planets are large, It is that those gaps are filled with a silence and simplicity that offer almost nothing for your senses to hold on to, allowing the idea of emptiness to expand in your thoughts as you drift between the worlds. When you first hear the distances between planets, stars, and galaxies, the numbers can feel as empty as the space they describe. Millions of kilometers, billions of kilometers, light years. These phrases stack up until they blur together. Your mind tries to hold them all at once, then quietly lets them slide into a single impression of something enormous. That reaction is not a failure. It is a normal response from a brain built to judge the length of a room or the time it takes to cross a field, not the width of a planetary orbit. Astronomers handle this by breaking distance into steps and by repeating their measurements many times. For nearby objects, they might send radar signals, timing how long the echoes take to return. For planets, they follow paths of spacecraft, watching how their orbits shift under gravity. For stars, they measure tiny changes in apparent position as Earth moves around the Sun, building a kind of cosmic triangle that reveals how far away the star must be. Farther out, for galaxies, they use the brightness of well-understood objects as markers. Each method works reliably only over a certain range, so they layer them like overlapping bridges. You do not need to remember the details. What matters is the rhythm. Nobody understood these scales in a single step. Confidence grew from patient measurements, careful comparisons, and the steady habit of checking results against one another. In the same way, your own sense of distance can grow slowly. You might start with one simple idea, such as the time light takes to travel from the moon to Earth, a little more than a single heartbeat. Let that picture settle. Then add another step. The time light takes to cross the distance from the Sun to Earth, a handful of minutes. Over time, these anchor points give the larger numbers a place to rest. As you listen, you do not have to force anything. If your thoughts drift away from the exact figures and return to the feeling of lying still, that is completely fine. The story can continue on one level, while another part of your mind softens and unwinds. You might notice the weight of the blanket over you, or the way your breathing settles into a slower pattern. Just as astronomers return again and again to the same measurements until they become familiar, you can return to these ideas without pressure, letting them become background shapes rather than sharp questions. In this quiet state, distance stops being something you must conquer. It becomes a gentle backdrop, a reminder that you are small in a very large setting, yet secure in your own local corner of it. The vastness that once felt sharp begins to blur at the edges, like lights seen through half-closed eyes. You do not need to reach the planets or the stars. You only need to know that they are there, far away, measured with care, while you rest where you are. When you look up at the night sky, the stars can seem crowded. On a clear evening, the darker the surroundings become, the more points of light appear. They overlap in your vision, forming patterns and constellations, and it is easy to imagine that space must be densely packed with suns. Yet if you could move close to any one of those stars, you would find that its neighborhood is mostly empty. By human standards, stars live very far apart. Imagine placing the sun in an enormous dark hall. Around it you arrange other stars at their typical distances in our region of the galaxy. If the sun were reduced to the size of a bright marble, the nearest star would not be a step away or the length of the room away. It would be far outside the building, many kilometers beyond, so distant that the hall around your marble sun would be entirely empty. Our own sun and its nearest stellar neighbor are separated by several light years, which means light itself takes years to cross the gap. This wide spacing is not a coincidence. Stars are born inside large, cold clouds of gas and dust. Gravity slowly gathers parts of these clouds into denser regions, which collapse into hot, shining spheres. As they form, stars push away some of the surrounding material with their light and winds. Over time, many of the original clumps disperse. What remains is a population of stars moving through the galaxy, each one carrying its own system of planets, asteroids, and comets, separated from others by large stretches of space. If stars were packed much closer together, their gravity would disturb one another more strongly. Planetary orbits could be pulled into strange shapes or even torn apart. Close encounters between stars would strip systems of their outer worlds. The calm, nearly circular path that Earth follows around the Sun relies on the fact that other stars keep a respectful distance. The emptiness between them creates room for stable, long-lived orbits, where planets can circle quietly for billions of years without violent interruptions. From inside a galaxy, this structure is hard to feel. Stars appear side by side in the sky, their light overlapping. Telescopes show clusters where thousands of stars share a region, but even there, the average gap between them is vast compared with their sizes. A star that seems to sit just next to another in a photograph may be many trillions of kilometers away along the line of sight. The picture on the page is flat. The real arrangement is three-dimensional, with deep layers of distance hidden behind each point of light. Your senses are not built to separate those layers. They merge into a single pattern overhead. The mind then reads that pattern as one surface filled with bright marks. It does not see the silent spaces that stretch between the stars, or the long journeys a spacecraft would have to take to cross from one to another. Yet those invisible distances are the reality that shapes the galaxy. Space feels vast, in part because stars need room. Their light is close together only in your view of the sky. In the actual structure of the Milky Way, they are solitary fires, each one surrounded by a great volume of darkness that keeps its planets safe. The speed of light is one of the most important reasons space feels so remote. On Earth, you may think of light as almost instant. You flip a switch and a room brightens. A distant building appears clear the moment you look at it. Your experience teaches you that vision is immediate, so it is natural to assume that seeing something is the same as being close to it. In space, that link breaks. Distances grow so large that even light, the fastest signal in the universe, takes a measurable time to travel. Light moves at about 300,000 kilometers every second. In 1 second, it can circle Earth many times. That sounds limitless until you begin to place it in context. From the Moon to Earth, light needs a little more than 1 second. From the Sun to Earth, it requires around 8 minutes. If you were to watch the sun set, you would be seeing it as it was several minutes earlier, not as it is in the moment you look. On these scales, the delay still feels small, but it is already real. Now imagine a signal traveling from the Sun to the outer planets. To reach Jupiter, light needs tens of minutes. To reach Neptune, it needs several hours. A message sent to a distant spacecraft far beyond the main planets may take many hours to arrive, and just as long to return. Engineers who guide those craft must think in terms of round trips measured in half days, not instant commands. The distance is not defined only by kilometers, but by how long it takes even the fastest possible signal to cross it. Between stars, this delay grows into years. Light from the nearest star system beyond the Sun left there years ago before reaching your eyes or a telescope mirror. When astronomers study that system, they see it as it was back then, not as it is today. For more distant stars, the gap stretches into decades and centuries. For faraway galaxies, the light has been traveling for millions or billions of years. The farther you look, the longer the delay becomes, until the universe appears as a series of nested pasts. This link between distance and time changes how you experience space. On Earth, you are used to the idea that if you can see something clearly, you could in principle reach it quickly, at least compared with a lifetime. You might walk, drive, or fly, but the travel remains within a span that you can imagine living through. In space, seeing does not carry that promise. You can see a galaxy that no person, no probe, and no signal will ever reach, simply because the separations and the expansion of space are too large. You look, you receive the light, but the possibility of going there is absent. Your mind, used to local scales, tries to hold on to the old rule that visibility implies nearness. When the rule fails, it leaves a quiet sense of distance that is hard to describe in simple images. The stars and galaxies become both present and out of reach. They send light that touches you, yet the paths back to them are measured in years and ages. Space feels vast, not only because it contains many things spread far apart, but because the fastest messenger you know cannot bind them together in a way that fits comfortably inside a human lifetime. When you look at the night sky, you are not seeing the universe as it is right now. You are seeing layers of its past stacked together on the same canvas. The light from a nearby planet or from the moon began its journey moments ago. The light from the sun left several minutes earlier. The light from distant stars set out years ago. When you gaze at a galaxy far beyond the Milky Way, you may be seeing it as it was millions or even billions of years in the past. This idea is called look-back time, and it is another reason space feels so vast. On Earth, your senses are used to events happening together. When you watch people move in a room or cars travel along a street, everything appears to share the same present. If there are delays, they are tiny and invisible. A sound may reach you a fraction of a second after it is made, but you experience it as part of the same moment. Distance and time remain linked in a way that feels simple. The farther away something is, the smaller and quieter it appears, but it does not seem to belong to a different era. In space, distance stretches that link until it breaks the illusion of a single present. The farther away an object is, the longer its light has spent crossing the emptiness. When you look at a star 10 light-years away, you see it as it was 10 years ago. Any changes that have happened there since then have not yet revealed themselves to you. For galaxies, the gap is far larger. Some of the faint smudges recorded on telescope detectors show structures that existed when the universe was much younger, when stars were forming at different rates, and the overall pattern of matter was less settled. Astronomers use this property as a tool. By observing objects at different distances, they can assemble a kind of timeline of cosmic history. Nearby galaxies show one stage, more distant ones show an earlier stage, and the most distant ones currently visible show times very close to the universe's beginning. The sky becomes not just a map of where things are, but of when they were in different states. Yet to the eye, all of these layers occupy the same dome overhead. The human brain is left to merge multiple ages into a single impression. This stacking of timescales is not something your senses evolved to handle. Your body expects that what you see around you shares your present. When that expectation fails, the mind compensates by smoothing the differences together. It accepts that some stars are older in their light, some younger, but it holds on to a simple image of a starry sky. The finer detail remains in the background, as an idea rather than a vivid picture. Space feels vast because it is not only extended in distance, it is extended in time, with each extra layer of history arriving as a separate shell of light. You stand in one moment, surrounded by messages from many different moments, and the gap between them is measured in years, ages, and entire phases of cosmic evolution. To see why space feels so vast, it helps to step back in your imagination until you are no longer focused on Earth, the Moon, or the nearby planets, but on the structure that holds them all. Our solar system is not isolated. It lives inside a much larger arrangement of stars, gas, and dark matter called the Milky Way, a galaxy so large that even light needs tens of thousands of years to cross it from one side to the other. You are not just on a planet. You are inside a star system that itself is a tiny part of a sprawling island of stars. Picture the Milky Way as a broad, flattened disk with a thicker central region. If you could see it from the outside, it would resemble a soft spiral of light, with curved arms winding around a bright core. Inside this structure are hundreds of billions of stars, each with its own surroundings, and among them is the sun. Yet when you step out at night and look up, you see only a narrow band of hazy brightness stretching across the sky on very dark nights. That pale river of light is your edge-on view of the galactic disk, seen from within. Our solar system sits far from the crowded center, in one of the quieter spiral arms. The sun is not special in its position. It orbits the galactic core along with countless other stars, taking hundreds of millions of years to complete a single circuit. During that journey, star formation rises and falls in different regions, clusters drift apart, and gas clouds slowly change shape. On human timescales, these changes are so slow that the Milky Way might as well be fixed. On galactic timescales, it is a living, shifting structure. To understand the scale, imagine shrinking the entire galaxy until it is the size of a large city. In that city, the solar system would not be a house, or even a single room. It would be more like a grain of dust floating in one neighborhood. The planets would be smaller still, far too tiny to see. All of the familiar distances between Earth and the other worlds around the Sun would fit easily within a space so small that it would vanish in the map of the larger structure. The city is the galaxy. The dust grain is your local system. Astronomers cannot step outside the Milky Way to take a direct photograph. Instead, they infer its shape by observing how stars are distributed across the sky, how gas glows at different wavelengths, and how objects move under the pull of gravity. From these clues, they build a picture of spiral arms, a central bulge, and an extended halo of material around the disk. The result is a map assembled from many incomplete views, a reminder that the galaxy is too large to be grasped in a single glance, even with our best instruments. When you think of the Milky Way in this way, as an island of stars with our sun as only one ordinary light among many, the sense of vastness deepens. The enormous volume that contains your entire solar system becomes a small region within a still larger whole. The thick band of stars you sometimes see overhead is only the narrowest cross-section of the full structure. You live in one tiny part of that island, looking out from a small shore into distances that extend first across the galaxy and then far beyond it. From inside the Milky Way, you cannot simply take a wide photograph of the whole galaxy and admire its spiral shape. You are sitting on one of the countless stars inside the disk, looking through layers of gas, dust, and starlight in many directions at once. It is as if you were standing in a dense forest, trying to draw a map of the entire woodland by looking between the trunks. Some paths are clear, others are blocked, and you never see everything at once. Astronomers have had to learn how to map the invisible by combining many partial views into a single, larger picture. Dust is one of the main obstacles. Tiny, solid particles scattered through the galaxy absorb and scatter visible light, dimming objects behind them and changing their colors. To your eyes, these dusty regions can look like dark patches or lanes that cut across the bright band of the Milky Way. In some directions, they completely hide what lies behind. If astronomers relied on visible light alone, large parts of the galaxy would remain blank, as if nothing were there. To reach past the dust, scientists use light of other wavelengths. Radio waves, with their long wavelengths, can slip through dusty regions that stop shorter, bluer light. By tuning radio telescopes to the frequency at which cold hydrogen gas emits, they can trace out vast structures within the galactic disk. Infrared light also passes more easily through dust, revealing stars that are hidden in visible images. By combining radio and infrared maps, researchers begin to see the outlines of spiral arms, dense clouds, and streams of material that would otherwise remain hidden. Motion provides another clue. Stars and gas clouds orbit the center of the galaxy under the pull of gravity. By measuring tiny shifts in the wavelengths of their light, astronomers can determine how fast they are moving toward or away from us. These motions are not random. They follow patterns that depend on the overall distribution of mass in the galaxy, including material that does not shine. By comparing observed speeds with what would be expected from visible matter alone, scientists infer the presence of an extended halo of unseen mass surrounding the disk, a contribution often called dark matter. Distances also matter. Nearby stars can be measured with relatively direct methods, such as parallax, where their apparent positions shift slightly as Earth moves around the Sun. More distant regions require indirect approaches, using standard candles and other indicators. By layering distance estimates on top of maps of brightness and motion, astronomers slowly build a three-dimensional model of the Milky Way, even though no single observation reveals it all at once. The result is not a single, perfect picture, but a mosaic. Different surveys cover different parts of the sky. Some emphasize gas, others stars, others dust or high-energy emissions. Each piece adds another bit of structure to the overall pattern. Over years and decades, these pieces are adjusted and refined as new data arrives. The galaxy that emerges from this work is a reconstruction, a best understanding assembled from many partial glances. For most people, the Milky Way remains an image seen in diagrams and artists' impressions, a graceful spiral hanging in space. Behind those images lies this quiet, patient process of mapping the invisible. Space feels vast in part because our own home galaxy cannot be grasped in a single view. It stretches beyond the reach of any one instrument or method, forcing us to piece it together gradually. You live inside a structure so large that even with all our tools, we only ever see it in fragments, and yet those fragments are enough to show how wide and intricate your cosmic island truly is. Imagine that you could leave the solar system and rise slowly above the plane of the Milky Way, not in a sudden jump, but in a long, quiet drift. You are not cold or in danger. You are simply carried along, shielded and weightless, watching the galaxy unfold around you. Below, the sun becomes one star among many, a modest point in a pale, hazy band of light. As you move farther away, that band broadens and curves until you begin to see it as a flattened disk, faint but clearly shaped. Now picture yourself gliding gently above that disk, at a height where you can look down across the spread of stars. The central region appears thicker and brighter, where more stars crowd together. Farther out, the light thins and fades toward the edge. Here and there, dark lanes cut across the glow, places where dust blocks starlight. In other regions, faint patches reveal clusters and clouds where new stars are forming. The whole structure turns very slowly, so slowly that on human timescales it feels still. You drift along without any rush, crossing thousands of light years in thought without feeling any strain. Your breathing, wherever you are as you listen, can match this unhurried movement. Each slow inhale is like a small step along the arc of your path. Each slow exhale is a gentle pause while you look down at the stars beneath you. There is nothing you must do, no decision you must make. The galaxy is there whether you focus on one part or let your attention soften and spread. From this vantage point, the emptiness between stars is easy to see. Dark spaces lie between bright regions, not as sharp gaps, but as broad stretches where the glow thins. Within those spaces are countless unseen systems, each with its own planets and dust, but from afar they merge into a smooth background. The Milky Way appears not as a busy crowd of individual suns, but as a calm, continuous pattern of light. The complexity is there, yet from a distance it becomes simple. If your eyes grow tired, you can imagine closing them and still keeping the shape of the galaxy in mind, like a faint outline behind your thoughts. You know there is a bright core, curved arms, and a sprawling disk. You know the sun and earth are somewhere within that pattern, moving on paths that take ages to complete. You do not need to know exactly where. It is enough to feel that you are part of something wide and stable that extends far beyond any single point. In this mental journey, the numbers fall quiet. You are not counting light years or masses. You are holding a picture of a large, slow-turning structure that changes so gradually you could rest your whole life beneath it and never see it shift. The feeling of vastness is still there, but now it has softened edges. It is not pressing in on you. It is spread out around you like a distant horizon. As you remain with this image, your body can settle more deeply into whatever supports you. The surface beneath you, the weight of a blanket or the gentle touch of clothing, becomes your local anchor. Far above that anchor, in thought, the galaxy turns and glows. Between the two there is a long, calm distance filled with quiet. In that distance there is room for your mind to slow down, for thoughts to stretch and then gently fade, as the story continues its steady path through the wider universe. Floating above the Milky Way in your imagination, it is easy to think of this galaxy as the whole universe. It fills your mental view, a broad disk of light with a bright center and gentle arms. Yet even this immense structure is only one member of a larger family. If you could drift farther out, still calm and weightless, you would see that the galaxy you have been watching is accompanied by others, bound together by gravity into a modest group scattered across the surrounding space. The closest large companion to the Milky Way is a spiral system, often called our neighbor, a galaxy similar in size that lies at a considerable distance. Between the two stretches a deep, dark gulf, where there are no stars bright enough for your eyes to see at this scale. only a faint presence of very thin gas, stray stars, and small satellite galaxies wandering along the gravitational field that links the pair. The gap is measured in light years so numerous that they strain belief, yet in the wider universe this separation counts as a short reach. Around these two large spirals orbit smaller galaxies, some irregular and faint, others more clearly structured but modest in size. They move on long, slow paths, taking enormous spans of time to trace their orbits. The entire collection, with our Milky Way, its big companion, and the many smaller systems, forms what astronomers call a local group. It is not tightly packed like the stars in a cluster. Instead, it is a loose association, with each galaxy holding its own space and following its own trajectory, yet all of them linked by a shared gravitational influence. In your mind, you might picture this group as a scattering of islands in a dark sea. The Milky Way is one island, bright and detailed when you look closely. The neighboring spiral is another island some distance away, with its own internal currents of stars and gas. Dozens of smaller islands surround them, many so dim that you would need sensitive instruments to notice them at all. Between all of these lie vast stretches of water, not empty in a strict sense, but nearly featureless on the scales that matter to your eyes and body. Compared with the galaxy itself, the local group adds only one more layer to the sense of scale, yet that layer changes how you think about your place in space. You are no longer inside a single, solitary island. You are in a system of islands, each containing billions of stars. The distance from one to another is so great that light must travel for long periods to cross it, and any journey by spacecraft built from known materials would take much longer still. The gap between galaxies is not just wide, it is wide in a way that resists direct experience. Astronomers study this group by carefully measuring the motions and distances of its members. They observe how galaxies move relative to each other, how their shapes are distorted by tides of gravity, and how streams of stars sometimes stretch out between them, traces of past encounters. From this information they build models of the group's history and its future, showing how the members slowly approach or recede, how orbits curve and twist over times far longer than human history. For you, lying still while listening, it is enough to know that your home galaxy is not alone. It shares space with others, yet even those nearest companions are unimaginably far away. You can hold the image of a small collection of galaxies hanging together in the quiet of the larger universe. The Milky Way, which already felt vast, becomes only one part of this neighborhood. The distances between these parts are so large that they seem to blur into a continuous dark background, and in that background your thoughts can loosen, aware of the scale but not burdened by it, as the story prepares to drift outward again. From the vantage point of the local group, you might imagine that galaxies are scattered through the universe like dust shaken from a hand, each drifting alone in a uniform sea. If that were true, space would still be large, but its structure would be simple. Instead, when astronomers map large regions of the sky, they see a different pattern. Galaxies tend to gather. They form groups and clusters, dense knots, where hundreds or thousands of systems live in the same broad region, surrounded by stretches of space where far fewer galaxies appear. The reason for this pattern lies in gravity and in small differences that grew over time. In the early universe, matter was not perfectly even. Some regions were slightly denser than others. These tiny variations were almost invisible, gentle ripples in a nearly smooth field. Where the density was a little higher, gravity pulled more strongly, attracting more matter. As more material fell in, the pull grew stronger still. Over long periods, this feedback turned small ripples into pronounced hills of mass, where gas could cool and condense into galaxies. In areas that started slightly less dense, the opposite happened. There was less matter to pull things in, so those regions remained relatively empty. As the denser patches grew into clusters of galaxies, the emptier patches became the wide gaps between them. The universe, on its largest scales, took on a kind of texture, with thick knots and filaments of galaxies separated by stretches where very little material gathered. This structure is not visible to your eyes when you look up, because the distances are too great and your viewpoint is limited. It emerges from surveys that reach across huge volumes of space. Within a cluster, galaxies can be quite close by cosmic standards. They orbit the shared center of mass, sometimes passing near each other, sometimes colliding and merging into new, larger systems. Their shapes may be distorted by tides of gravity, and streams of stars can be drawn out between them. The cluster becomes a busy environment compared with the calmer outskirts where a single galaxy moves more quietly through space. Even so, the distances between individual galaxies in a cluster remain far beyond anything your body could relate to. They are crowded only in the language of cosmology, not in the language of daily life. The contrast between these dense regions and the surrounding emptiness adds another layer to the feeling that space is vast. It is not just a matter of size, but of distribution. You have islands of extreme activity, where many galaxies interact, set within wide stretches where almost nothing happens on scales that matter to human senses. The mind tries to imagine these structures as if they were landscapes, but no landscape on Earth combines such strong clustering with such deep emptiness over such immense distances. As you picture this, you might imagine yourself moving slowly outward from the local group. You pass through quieter space where a few galaxies drift alone, then approach a cluster where hundreds gather together. Beyond that, you move into another sparse region. The alternation of crowded and quiet zones continues on and on. There is no single center to this pattern that you can stand in and see it all. From any one place, the true extent is hidden. You know it only through careful mapping and through the calm realization that the universe is not only too large to walk across. It is also arranged in a way that blends concentration and emptiness on scales so big that they can only ever be held in thought. If you could pull even farther away from the local group and its neighboring clusters, the universe would begin to reveal one of its most striking patterns. Galaxies, groups, and clusters do not fill space evenly. When astronomers map their positions across large volumes, a new shape appears, one that cannot be seen from any single small region. The galaxies trace out long, thin strands and flattened sheets of matter that stretch across hundreds of millions of light years. Between these strands lie enormous regions where very few galaxies are found at all. The result is often called a cosmic web. Imagine looking at a faint, three-dimensional lace made of light. The threads of this lace are galaxy filaments, long structures where many systems are gathered. At the points where several threads meet, clusters form, dense knots of galaxies bound together by gravity. Beyond the threads and knots are wide, dark hollows. These hollows are not perfect voids, but they contain far less matter than the filaments. On human scales, each hollow is so large that entire clusters could drift through it and still have room to spare. This pattern did not appear instantly. It grew slowly from the same small differences in density that gave rise to clusters and groups. Regions that began slightly denser drew in more material, forming not just isolated knots but extended ridges. Over cosmic time, matter flowed along these ridges, feeding clusters at their junctions. Computer simulations that follow the behavior of dark matter and gas under gravity show similar structures emerging, even when the starting conditions are very simple. The web seems to be a natural way for matter to organize itself on the largest scales. From any single point inside this network, you cannot see the whole thing. Your view is limited by distance, by the horizon set by the age of the universe, and by the capabilities of instruments. Astronomers piece together the web by measuring the positions and redshifts of many galaxies, and then plotting them in 3 dimensions. When these maps are rotated and sliced, the filaments and voids become visible. They look like a frozen foam of structure, with bright lines of galaxies forming the walls and dark regions filling the spaces between. For the human mind, this scale is especially difficult to grasp. Even a single filament can span so far that light requires hundreds of millions of years to travel from one end to the other. The voids enclosed by these filaments are just as large or larger. No journey you can imagine making, even with perfect technology, fits easily into such distances. The familiar idea of a landscape, with mountains, valleys, and oceans, breaks down. Here, the features are too large and too slow for any direct experience. Yet there is a quiet order in this arrangement. The web does not change much over a human lifetime. Its main structures are already in place, evolving only gradually as galaxies move, merge, and fade. You can think of it as a giant frame that holds the universe together on the broadest scales, a framework of mass on which everything else hangs. Your galaxy, your local group, and the clusters near you are small patterns woven onto this framework. As you picture this web, it is natural for your imagination to reach a limit and then soften. You may hold a vague image of threads and hollows, knowing that the real structures are far larger than anything you can truly picture. That is enough. The point is not to see every detail, but to sense that the universe has a shape that extends far beyond galaxies themselves. Space feels vast here, not only because it is large, but because its largest patterns are so extended that they can only ever live as gentle outlines in your thoughts, while your body remains still in a much smaller, familiar world. Once you are thinking in terms of filaments that span hundreds of millions of light years and voids that are just as wide, numbers begin to behave differently. They stop feeling like counts and start feeling like symbols. A light year is already a difficult unit to picture. The distance light travels in a full year of continuous motion. When you multiply that distance by tens, hundreds, or thousands, your imagination quickly reaches a point where it cannot form a clear picture. The figures enter your mind, then dissolve into a soft sense of immensity. This is not carelessness. It is a natural response from a brain that evolved to judge the length of a field or the height of a tree, not the diameter of a cluster. You can imagine 10 steps, or 100, or even a long walk measured in thousands of steps. Beyond that, your thoughts move from direct experience to abstract counting. In a similar way, you can imagine 10 years, perhaps 50 years, maybe a long human life. When numbers reach into millions of years or billions of years, they lose their connection to personal memory and expectation. They become labels for something that exists far outside your lifespan. Astronomers work with these numbers every day, yet they feel the same limit. To keep their footing, they often use comparisons. They might say that a certain galaxy is one of the largest in a sample, or that a filament in a map stretches across a fraction of the observable universe. They relate one enormous quantity to another enormous quantity, building a kind of internal scale made entirely of things that no one has ever directly experienced. The relationships become familiar, even if the absolute sizes remain beyond full visualization. For most people, it is easier to think in layers. You may remember that the solar system spans light hours to light days, that the galaxy spans tens of thousands of light years, that the cosmic web stretches across hundreds of millions. You might not hold the exact values, only the order in which they grow. This ladder of scale, with each step many times larger than the one before, is enough to convey the sense that the universe is not just big, but structured in levels of vastness. Each level is too large to cross in a personal way. Together they form a staircase that reaches far beyond any journey you can imagine. At some point, the effort to picture these sizes becomes like trying to see every grain of sand on an entire shore at once. Your mind knows they are there, yet it cannot represent them individually. The correct response is not to strain harder, but to accept that this is where thought shifts from images to understanding. You know that the numbers describe a real structure outside you, even if your inner pictures remain soft and approximate. In that acceptance, the universe does not shrink. It stays as large as it is, while your expectations adjust. The feeling that space is vast becomes quieter and steadier, less like a shock and more like a simple fact that rests at the edge of awareness. After thinking about the sizes of structures in the universe, it is natural to wonder how all of this came to be. One of the most surprising discoveries of the 20th century was that space itself is not static. When astronomers measured the light from distant galaxies, they found that most of them appear to be receding, with their light shifted toward longer wavelengths. The farther away a galaxy is, the more its light is stretched. This pattern suggests that space is expanding, slowly increasing the distances between far separated systems over time. A useful way to imagine this is to picture a flexible surface marked with small dots. The dots stand for galaxies. When the surface is gently stretched, each dot moves away from the others. not because it is traveling across the surface, but because the surface itself is expanding underneath it. Nearby dots drift apart slowly. Distant dots separate more quickly because there is more stretching between them. No dot has a special central position. Each one can regard itself as the middle of the pattern, seeing others recede in all directions. In the real universe, space has 3 dimensions rather than 2, but the principle is similar. On very large scales, the average distance between far-flung galaxies increases with time. Local systems like galaxies and groups remain bound together by gravity and do not participate in this expansion in the same way. Your solar system does not swell with the cosmic growth. The galaxy does not slowly tear itself apart. Instead, expansion matters most when you look across gaps so wide that gravity has less influence. There, the stretching of space becomes important. This idea changes how you think about distance. It is no longer just a static separation that you could, in theory, cross given enough time. It is something that can grow even as light travels across it. A beam of light that leaves a distant galaxy may find that the space it passes through is expanding as it goes, so its wavelength stretches along with the distance it covers. By the time it arrives at a telescope on Earth, it carries within its color a record of how much the universe has grown during its journey. When you picture this, it can feel as though the universe is pulling away from itself, or as though everything is rushing apart. That impression can be unsettling if you think in human terms, where motion often implies separation and loss. On cosmic scales, the process is more like a slow, steady drift that has been underway for most of the history of the universe. It does not demand a personal response. It simply means that the large-scale fabric of space has a history, and that history is written into the distances between the most distant objects you can see. Space feels vast in a new way when you consider expansion. It is not only that galaxies are far apart, it is that the stage between them is active, changing gradually over time. The separations you measure today are part of a longer story. They are one frame in a sequence that extends backward and forward, a reminder that the universe is not a fixed arena but a dynamic setting where size itself evolves. The idea that space can expand is difficult to hold in a single clear picture, especially when you are tired or drifting towards sleep. Your mind might try to imagine all distances stretching at once, then run into contradictions. You may wonder what space is expanding into, or what happens at the edges, only to learn that the concept of an edge may not apply in the usual way. These questions can tangle together if you chase them too hard. For a moment, it is helpful to set them down and let the idea become simpler. You can think of the universe as a pattern of galaxies and matter that changes slowly with time. When cosmologists say that space is expanding, they mean that as this pattern evolves, the average separation between distant galaxies grows, local structures remain bound, the chair beneath you, the Earth under that chair, the solar system that holds Earth in orbit. All of these are governed by forces much stronger than the gentle pull of expansion on small scales. They do not stretch in any noticeable way. The growth appears only when you look across the largest gaps. If you like, you can match this large-scale change to the rhythm of your own breathing, not as a literal connection, but as a simple image. As you inhale slowly, you might picture the spaces between far-off galaxies growing slightly wider over enormous times. As you exhale, you might picture the galaxies themselves continuing on their paths, bound within clusters, interacting, colliding, and merging under gravity. The expansion is present, yet it is not a sudden event. It is a background process, continuing whether you think about it or not. There is no requirement to see this perfectly. Even people who work with the equations that describe expansion rely on simple mental models most of the time. They grasp the full complexity through mathematics and observation, then translate it into plain language when they explain it to others. You can do something similar at your own level. You might keep a modest picture in mind. The large-scale universe is slowly growing in its separations, while smaller structures remain held together. As you rest, you can let this understanding sit quietly at the edge of your awareness. The details can fade, leaving only a general sense that the universe is vast and in motion, but not in a way that demands your action. The galaxies will continue to drift apart on very large scales, regardless of what happens in your own small corner. That distance between scales can be calming. Your body follows its own cycles of waking and sleeping, of tension and release, while far away the cosmos follows cycles measured in ages. You do not need to keep pace with it. You can let your thoughts slow, knowing that the story of expansion will continue gently in the background as you drift deeper into rest. Looking out into a universe where space expands, you eventually encounter a limit that has nothing to do with technology and everything to do with time. Light travels at a finite speed, and the universe has existed for a finite age. That means there is only so much of it that has had time to send light or other signals to you. The region from which light has managed to arrive since the beginning forms a kind of horizon around you. Beyond that horizon, galaxies may exist, but their light has not yet, and in some cases will never, reach your eyes or instruments. You can imagine this horizon as a large, spherical boundary centered on your position, although the exact shape is more subtle once you account for expansion. Within this boundary, every direction you look reveals objects at various distances and look-back times. The closest stars lie right next door in cosmic terms. The most distant visible galaxies sit near the edge, their light stretched and faint after traveling for most of the universe's history. Beyond that lies a region that current observations cannot penetrate, not because instruments are weak, but because there has not been enough time for information to cross the gap. The presence of such a horizon does not mean the universe ends there. It simply marks the edge of what can influence you or be influenced by you through signals that travel at or below the speed of light. Regions beyond may contain countless galaxies, structures, and events, continuing the patterns you see or perhaps diverging from them in ways you will never know. In principle, no message, spacecraft, or beam of light sent from your location today could ever catch up with some of those regions. They are permanently outside your causal reach. Astronomers distinguish between different kinds of horizons, depending on whether they are thinking about the past, the future, or the present structure of space. One important version is the observable boundary, the limit from which light has reached us so far. Another concerns which regions will ever be reachable, even with infinite time, in an expanding universe. These distinctions matter in technical work, but for a quiet understanding, it is enough to know that there are natural limits to what any observer can see or affect. This idea adds a new layer to the sense that space is vast. It is not only that distances are huge, or that structures are enormous, or that numbers strain belief. It is that there are regions of reality that are completely beyond contact, not because you have not yet found a way to reach them, but because the laws of physics prevent any link from ever being formed. You live inside a cosmic bubble of information, large by any measure, yet still only a part of a larger whole. Thinking about this can make the universe feel both larger and more intimate. Larger, because you know there is more beyond what you can ever see. More intimate, because everything that can ever touch you through light or gravity is contained within a finite region. Your life, your planet, your galaxy, and all the objects whose light reaches you share a connected domain. Outside it, the universe continues in silence, a reminder that even the horizon of your awareness is only one piece of a reality that extends farther than any map will ever show. Among the signals that reach you from near the edge of the observable universe is a faint glow that fills the sky in every direction. It does not come from any single star or galaxy. Instead, it is a remnant from a time when the universe was much hotter and denser than it is now, a leftover light from an early stage that has been stretched and cooled as space expanded. This glow is often described as a background, a soft echo that carries information about the conditions that existed when the cosmos was far younger. Today, this background appears as microwave radiation, with a temperature only a few degrees above absolute zero. Sensitive instruments detect it not as a smooth field, but as a pattern with tiny variations in temperature and brightness. These variations are small, but they are significant. They mark places where the density of matter was slightly higher or lower than average in the early universe. Over time, those small differences grew into the larger structures you have already imagined. Galaxies, clusters, filaments, and voids. The background light is therefore a kind of fossil image of a much earlier stage, still visible to you billions of years later. Astronomers map this background by surveying the sky at microwave wavelengths and measuring its properties with high precision. The resulting images show a mottled pattern, like a very fine, grainy texture, where each tiny patch corresponds to a different region of the early universe. By analyzing these patterns, scientists infer the overall composition, age, and geometry of the cosmos. They learn how much matter and radiation it contained, how fast it expanded, and how the seeds of later structure were planted. There are other backgrounds as well. Diffuse radiation at infrared, X-ray, and gamma-ray energies arises from the combined light of many distant objects and processes. Together, these backgrounds form a kind of quiet chorus, each voice carrying information from a different era or type of event. Unlike the sharp light of individual stars or galaxies, they are not tied to specific points in space. They wash across the sky as whole fields, reminders that the universe has a history that cannot be reduced to a list of discrete sources. For your sense of scale, these backgrounds serve an important role. They show that even the most distant structures you can see are part of a larger story that began in a state very different from the present one. The faint glow you measure today has been stretched across unimaginable expanses of space and time. It has traveled through the growth of the cosmic web, past forming and merging galaxies, past generations of stars, before finally reaching detectors built on a small planet around an ordinary star. When you picture this, space feels vast, not only because of where things are now, but because of how far their influence has traveled and how long that journey has taken. A signal that began as intense radiation in a young, dense universe has become a cool, gentle background in an older, more spacious one. That transformation is written into the properties of the light itself. You are, in a sense, listening to a soft echo from an era when everything that now seems far apart was much closer together. A reminder that the immense distances you contemplate today have grown from something once far more compact, and that the story of that growth is still arriving, quietly, as you rest beneath the sky. When you look at the night sky with your unaided eyes, you see only a thin slice of what is really there. Your vision is limited to a narrow range of wavelengths, and your pupils can collect only a small amount of light in each moment. For most of human history, this was all anyone had. The universe felt large even then, but its richness was hidden. Only when people began to build instruments that could gather and concentrate light did the true depth of space start to reveal itself. Telescopes, detectors, and spacecraft became extensions of the senses, quiet tools that increased the reach of human perception. A simple optical telescope takes the light that would normally fall across a wide patch of ground and funnels it into a small area where it can be examined in detail. Glass lenses or precisely shaped mirrors bend incoming rays so that they meet at a focus. There, the light that would otherwise pass unnoticed can be recorded by an eye or a camera. Faint stars that were invisible before appear as sharp points. Nebulae that were once mere hints of brightness become clouds with structure. Each improvement in mirror size or lens quality translates into a deeper view of space. Radio telescopes work in a similar way, but with much longer wavelengths of light. Their large dishes collect weak radio waves from clouds of gas, distant galaxies, and energetic events that do not shine strongly in visible light. To the human ear, these signals would be silence, but to sensitive receivers they become measurable variations in voltage over time. Arrays of dishes spread across wide distances can act together as a single, larger instrument, increasing resolution. Through these tools, astronomers can trace structures that would otherwise be entirely hidden behind dust or too cold to glow in visible colors. Space-based observatories extend perception even further by rising above Earth's atmosphere. The air that protects you and scatters sunlight also absorbs large portions of the spectrum. High-energy photons from distant galaxies, ultraviolet light from young stars, and some bands of infrared radiation are blocked before they can reach the ground. By placing telescopes in orbit, engineers give them a clear view of these wavelengths. Detectors cooled to very low temperatures register even tiny amounts of incoming energy, turning distant, faint signals into reliable data. Every photon that reaches a detector carries information. Its energy tells you something about the process that created it, Its direction tells you where it came from. Its arrival time can be compared with others to reveal patterns of variation. Instruments are designed to count these photons, separate them by wavelength, and measure their properties with care. The raw output is not a picture in the usual sense, it is a stream of numbers, each one representing a small piece of the universe sampled at a particular place and time. Over years and decades, these measurements accumulate. Observatories scan the sky systematically, building catalogues of stars, galaxies, and other sources. Spacecraft traveling through the solar system measure magnetic fields, particles, and dust. Together, these observations form an extended nervous system for the species, reaching far beyond the physical limits of any single body. Where your eyes would see darkness, instruments see structure. Where your skin would feel nothing, sensors register subtle changes in fields and radiation. The feeling that space is vast deepens when you realize how much of what you know about it comes from such delicate traces. The most distant objects you can study are present to you only as a small addition to a detector's count rate, a slight change in a spectrum, a tiny excess above background noise. Yet from these quiet signals, interpreted through careful analysis, an entire picture of the universe emerges. Your natural senses end at the surface of Earth. Your extended senses, carried by metal and glass, reach across the solar system and out into the depths of the galaxy. They do not make the universe smaller, they simply allow you to see more of its immensity, one measured photon at a time. When an instrument records light from the sky, it does not see a nebula or a galaxy the way your eyes do in a photograph. It collects counts. A detector sits at the focus of a telescope and registers each incoming photon as a tiny event, a brief signal on an electronic circuit. Over time, these signals build into a pattern. Some regions produce more counts, others fewer. Different wavelengths yield different sets of numbers. By themselves, these tables and arrays do not look like space. They look like rows of values, quiet columns of measurements. To turn those measurements into something that a human mind can grasp, astronomers must translate them. One simple way is to assign each point in the data to a position on a plane, and then vary brightness according to how many photons arrived there. A dense region becomes a bright patch, a sparse region becomes faint. Already, a shape appears. Where there were only numbers, there is now a visible structure, a smear of light or a cluster of points that hints at something in the sky. Color is another step in this translation. Many detectors are sensitive to only a few broad ranges of wavelengths, or even to a single band that lies outside human vision, such as radio or X-ray. To make these data visible, scientists choose colors to represent different energies or elements. One wavelength might be mapped to red, another to green, another to blue. When these are combined, the result is a composite image where subtle differences become clear. Areas rich in one type of emission glow in one tone, while other regions stand out in another. These colors are honest but not literal. They do not show the universe exactly as it would appear to an unaided eye at that place. Instead, they reveal patterns in temperature, composition, or motion that would otherwise remain hidden. The choice of color scale matters. A softer palette can make a nebula look like a gentle cloud. A sharper contrast can bring out fine filaments and shock fronts. In each case, the goal is to make features visible and meaningful, to give the data a form that the brain can recognize and remember. Beyond images, there are other ways to translate measurements. Graphs that plot brightness against wavelength show how much light is emitted at different energies. Peaks and dips in these curves indicate the presence of particular atoms or molecules. Charts that record changes in brightness over time reveal cycles, flares, or the passing of objects in front of one another. Maps that layer many observations together show how gas, stars, and dark matter are arranged within a galaxy or cluster. Each of these visualizations turns an invisible relationship into a shape that can be seen at a glance. From these shapes, stories begin to form. When you see a spiral galaxy in a carefully processed image, you are looking at the result of this long chain of translation. The bright arms tell of regions where stars are forming. The darker lanes suggest dust that absorbs light. The central bulge hints at a dense, old population of stars and perhaps a massive black hole. A single frame captures not just a picture, but a history that scientists have inferred from many lines of evidence. The story is not invented freely, it is drawn out of the data, step by careful step. For people who are not involved in the measurements themselves, these final images and narratives are often the first contact with distant parts of the universe. They shape how space feels. A photograph of a star-forming region, with soft colors and curling clouds, can make the cosmos seem rich and intricate. A map of large-scale structure, with points representing entire galaxies, can make it seem sparse and skeletal. Both begin from streams of numbers collected by instruments. Both are honest translations of different aspects of the same reality. When you look at such an image, whether in a book, on a screen, or in your imagination, you are seeing the end result of an extended chain that starts with individual photons crossing the darkness. The sense that space is vast is carried along that chain. It is preserved in the way faint features become visible when long exposures are combined, in the way distant objects appear small and pale even after enhancement, and in the way labels on a caption quietly note distances and times that dwarf any familiar measure. Knowing that these pictures are translations can be calming. You do not have to hold every technical detail in mind. It is enough to remember that behind each graceful swirl of light lies a patient process of measurement and interpretation. The universe sends a steady rain of signals. Instruments catch them. People turn them into shapes and stories. You, resting where you are, receive those stories in a form your mind can follow, letting the images of distant structures drift through your thoughts while the reality they represent remains spread across distances far larger than any field, any sea, or any sky you have ever stood beneath. There is a particular feeling that often arises when you think about the size of the universe for more than a moment. It is not just curiosity and not just fear. It is a mixture of awe, smallness, and a sense that you are standing at the edge of something that cannot be fully grasped. Philosophers sometimes call this feeling the sublime. It appears when your mind encounters scales or patterns that are far larger than anything it was built to handle, yet still feels a pull toward understanding them. You may have felt a version of this while looking at a dark, star-filled sky from a quiet place. The usual sounds of daily life fade, and above you is a depth of brightness that seems to have no end. Another version can arrive when you see images of distant galaxies, or hear that some of the light reaching you tonight began its journey when no humans existed. In those moments, your thoughts stretch outward until they reach a point where they cannot stretch further, and then they hover there, unsure whether to retreat or simply rest. Inside your brain, several things are happening. Part of your mind is trying to build a clear model of what you are hearing or seeing. It attempts to place objects into a mental space, link them with distances and times, and fit them into a story that makes sense. Another part is monitoring how that attempt feels. When the information is just complex enough, the effort can be pleasant. You feel engaged, challenged in a gentle way. When it goes beyond a certain point, the effort becomes too much, and the brain signals that the material is overwhelming. The sublime often sits exactly at that boundary, where understanding is close but never complete. People respond differently to this boundary. Some feel a kind of dizziness, as though the ground beneath their everyday thoughts has dropped away. Others feel a deep calm, as if the vastness of the universe makes their own worries seem lighter. Many feel both at different times. A number that marks a huge distance can be frightening if you focus on how small you are in comparison. The same number can be comforting if you focus on the stability that such size implies, the sense that the universe is not easily disturbed by small events. Psychologists have found that experiences of awe and sublimity can shift attention away from the self. When you focus on something much larger than you, your mind gives less weight to your own small concerns, at least for a while. The sense of I softens slightly and becomes part of a broader scene. When you think about galaxies, clusters, and the cosmic web, you are reminded that you live inside a context that has existed for eons and will continue long after your own life has ended. This perspective can be unsettling if you cling tightly to the idea of control. It can be relieving if you allow yourself to feel that you are carried within something larger. The brain uses shortcuts when it handles these feelings. It cannot keep track of every detail about the universe, so it compresses them into simple impressions. A cluster of galaxies becomes very crowded. A void becomes almost empty. The observable universe becomes immense. These labels are less precise than the underlying numbers, yet they are more manageable. They let you hold the idea of vastness in a single thought without needing to recall every figure and definition. The sublime arises when these compressed impressions remain powerful even after the numbers fade. Cultural stories shape this experience as well. For some, the night sky carries religious or spiritual meanings. For others, it represents the success of science in uncovering patterns that were once hidden. For many, it is tied to childhood memories of lying outdoors and watching stars appear one by one. All of these associations color how the vastness of space feels. The same information that makes one person anxious can make another feel quietly connected to something enduring. As you listen, you do not have to decide exactly what the universe means to you. It is enough to notice how your own mind responds when it tries to think on these scales. Perhaps you feel a small tightening in your chest, or an opening, or a sense that your thoughts are stretching and then slowing. The feeling that space is vast is not a simple reaction to the size of the cosmos. It is a conversation between those outer scales and your inner limits. Somewhere in that conversation, in the point where understanding reaches out and then gently stops, the sublime takes shape. It lingers at the edge of thought, neither fully explained nor entirely mysterious, a quiet reminder that you are a small thinking being inside a very large, unfolding universe. When you think about the universe at its largest scales, it can feel as if everything familiar has been taken away. Distances reach beyond any journey you can imagine. Time scales stretch beyond any memory. Patterns like the cosmic web are so large that they refuse to fit inside your usual sense of space. In moments like that, it helps to return to small, steady anchors, simple reference points that connect the vastness of the cosmos back to something you can hold in your mind without strain. One of these anchors is the size of Earth itself. You may not know its exact diameter in kilometers, yet you carry an intuitive sense of what a planet is in relation to your body. You can picture its surface curving away beneath you. Imagine an airplane crossing an ocean in hours, or a satellite circling the globe in a short period of time. When you hear that the moon is roughly 30 Earth diameters away, that comparison gives you something solid to work with. The moon becomes not just a glowing disk in the sky, but a companion whose distance can be counted in units tied to your home world. Another anchor is the time it takes light to travel from the sun to Earth. 8 minutes is a span you can feel. You can imagine waiting that long for water to boil, for a short walk, or for a break to pass. Knowing that sunlight left the sun 8 minutes ago before touching your skin gives the distance between star and planet a human rhythm. The same is true for the 1 or 2 seconds it takes light to cross the Earth-Moon gap. These intervals are small enough that your sense of time can stay engaged, rather than shut down. You can also use familiar features in the sky as anchors. A bright planet near the horizon, a familiar constellation, or the soft band of the Milky Way on a clear night, can all serve as fixed points in your inner map. You may not know their exact distances, but you know they are consistent. Season after season, they rise and set according to patterns that repeat. Even as you learn that some of these lights are nearby stars and others are distant clusters, that stability gives your thoughts something to rest against while they explore larger scales. Scientists rely on similar anchors in their work. They use well-measured distances within the solar system as a base, then extend outward using objects whose brightness is predictable, gradually building a chain that reaches to galaxies and beyond. In their calculations, certain stars, certain types of supernovae, and certain patterns in the cosmic background become standard points of reference. Without these, the numbers would float without context. With them, each new measurement can be tied back to something known. As you lie still and listen, you can choose 1 or 2 anchors of your own. Perhaps you hold in mind the idea that the moon is a little more than a light second away, or that the sun is 8 light minutes distant. Perhaps you picture Earth as a small sphere surrounded by a thin atmosphere and a quiet orbit. You do not need many such images. A few simple ones are enough to keep the vastness of space connected to scales that your senses understand. If thoughts about the size of the universe ever feel too large, you can gently return to these anchors, just as you might return your attention to the feeling of your breath or the weight of the blanket over you. The galaxies, clusters, and filaments can drift into the background for a while, still there, but softer. Close by, in your imagination, Earth and its immediate surroundings remain clear. You are resting on a familiar world, one small anchor within a very large setting, and that is all you need to hold for now. When people talk about space, they almost always reach for comparisons. They call it an ocean, a desert, a web, a city of stars. These metaphors are not decorations. They are tools your mind uses to bring something too large for direct understanding into the range of familiar experience. Each one selects certain features of the universe and quietly leaves others aside. In doing so, it shapes how vastness feels long before any numbers enter the picture. If you picture space as an ocean, you may imagine waves, currents, and depths. Ships become spacecraft, islands become planets, and harbors become orbits. This image makes it easy to think about travel and navigation. You can imagine routes, tides of gravity, and storms of radiation. It also suggests that space is filled with something, the way water fills the sea. The emptiness between stars turns, in your mind, into a medium that can be sailed, even if it is in fact almost completely vacuum. The ocean metaphor brings movement to the foreground and pushes true emptiness slightly out of view. When you think of space as a desert, a different feeling arises. Now the emphasis is on dryness, silence, and isolation. Each planet or star becomes like an oasis, separated from others by long stretches of nearly featureless terrain. The difficulty of travel and the scarcity of resources come to mind. You imagine a harsh environment where life must be carefully protected. The desert metaphor can make the universe feel more hostile, yet it also conveys the vast, open character of interplanetary and interstellar distances. It highlights the sense that there is more nothing than something. The web metaphor, often used for the cosmic web, brings out connection and structure. Filaments of galaxies become strands in an enormous network. Clusters are junctions where many strands meet. Voids are the spaces between threads. In this picture, the universe feels less like an empty stage and more like a woven object, a fabric with tension and pattern. It can make the large-scale structure feel intricate rather than barren, emphasizing relationships rather than gaps. At the same time, it may tempt you to imagine the universe as delicate, like a spiderweb, when in reality its structures are massive and extremely durable on human timescales. Calling the galaxy a city of stars draws on yet another set of associations. Streets and neighborhoods become spiral arms and clusters. Bright centers suggest downtown districts. Outskirts hint at quieter suburbs. This metaphor can make the Milky Way feel busy and populated, full of activity and variety. It helps you imagine different regions with different characters, some dense and energetic, others sparse and calm. Yet it also risks compressing scale, because cities are small compared with the distances involved. The mind may unconsciously shrink the galaxy to something that could be crossed in a way similar to a familiar urban space. Even the word space itself is a kind of metaphor. It suggests a container, an emptiness that can hold things, that can be helpful when you think about objects moving and interacting. It can also be misleading if it leads you to picture space as a static box rather than as a dynamic part of the universe that can expand, curve, and evolve. The language you use quietly guides your expectations about what space can do and how it should behave. None of these metaphors is completely accurate, and none is entirely wrong. Each shines a small light on one aspect of the universe and leaves the rest in shadow. The important thing is not to avoid metaphors, but to be aware of their influence. When you feel that space is vast, ask yourself what image your mind is using. Are you thinking of a sea, a desert, a web, a city, or something else entirely? How does that choice make you feel about distance, emptiness, and connection? You can adjust those images if you wish. If a hostile desert picture makes the universe feel too harsh, you might shift to a calmer view, like a wide, still plain under a large sky. If an ocean picture makes it seem too crowded with invisible currents, you might focus instead on the quiet stability of orbits within a largely empty volume. You are not changing the physics by doing this. You are changing the frame in which your mind receives it. In this way, metaphors become small steering tools for your thoughts. They do not alter the size of the universe, but they can soften or sharpen how its size feels. Recognizing that your sense of vastness passes through language on its way into your mind gives you a measure of control. You can choose images that keep curiosity alive while allowing your thoughts to remain calm. The galaxies, clusters, and filaments do not depend on your metaphors to exist, but the path they take through your imagination does. During an ordinary day, the universe rarely announces itself. You wake up, move through your rooms, prepare food, speak with people, travel between places. Clocks measure hours, not ages. Distances are counted in steps, streets, or perhaps in the time it takes to cross town. Somewhere above all of this, the Earth is turning, the planet is moving along its orbit, and the sun is circling the center of the Milky Way, yet none of these motions disturb your morning. The vastness of space is present, but it stays in the background, like a quiet backdrop that does not demand your attention. As you walk outside, the sky might be bright and pale, hiding the stars completely. The sun dominates the view, a single source of light that washes away the galaxies. You see trees, buildings, and people instead of nebulae and clusters. This is not a lesser reality. It is the scale at which your senses and body are meant to work. You navigate curbs and crossings, doors and stairways. Your muscles, balance, and vision cooperate smoothly, tuned to the pull of gravity at the surface of one planet. The universe is large, but the part that matters most to you is this thin layer of ground and air. Even when night comes, the practical tasks of life remain local. You turn off screens, tidy small spaces, maybe set things in order for the next day. Lights in your home soften or go out. Outside, distant street lamps and windows make their own constellations, much closer than the stars. You move through a pattern of familiar actions, each one contained within a few meters. The largest distances you cross in these moments are from one room to another, from one side of a bed to the other. The cosmic web does not enter your thoughts unless you invite it in. Yet all the while, the vast structures you have imagined are still there. The solar system continues along its path around the galaxy. The galaxy continues along its path within the local group. Filaments and clusters hold their shapes on timescales far beyond any human calendar. Expansion, background radiation, and distant horizons remain, but they do so without pressing on your everyday choices. They are like a landscape far beyond the walls of your house, real but not intrusive. As you settle towards sleep, you can let this layering of scales become a source of calm. Your body lies on a surface that is solid and close. Around you is a room whose edges you know even with your eyes closed. Beyond that room is a building, a street, a neighborhood, all resting on the crust of a planet that you will never need to cross in its entirety. Far beyond that are orbits, stars, galaxies, and the quiet geometry of the universe. Each layer is larger than the one before, but you are held securely in the smallest one. If thoughts about space drift into your mind as you lie still, they do not have to be sharp or demanding. You can let them take the form of a simple awareness that above your ceiling, beyond the atmosphere, and across immense distances, the universe continues in its slow motions. None of that requires you to move. None of it requires you to understand every detail. You are free to remain exactly where you are, breathing at your own pace, while a vast, stable cosmos exists around you. In this way, the size of space becomes not a weight pressing down, but a wide, distant background that leaves room for rest. Your worries occupy only a tiny part of the whole, and even they can loosen their grip as you sink deeper into your immediate surroundings. You are a small, thinking being under a large, quiet sky, and for now it is enough simply to feel supported by the ground, covered by the night, and gently carried within a universe that is far bigger than you need to hold in mind as sleep comes closer. Human lives are measured in spans that feel tangible. You can imagine a year by thinking of seasons, holidays, or changes in the light through your windows. A decade can be pictured through memories of where you lived or worked, how people around you have changed, how children have grown taller. A human lifetime, perhaps many decades, is long enough to see cities evolve, technologies appear, and relationships deepen and fade. These are timescales your mind was built to handle, with a beginning, a middle, and an end, that can be held in one broad view. When you compare those spans to cosmic time, a new contrast appears. Stars live for millions to billions of years. Some very massive stars burn hot and die young on stellar scales, yet still exist far longer than any human civilization has so far endured. Other stars, smaller and steadier, can shine for tens of billions of years. Galaxies change shape slowly as stars are born, age, and die within them, and as they merge with other systems. The large-scale structure of the universe shifts even more gradually, its filaments and voids evolving over ages that dwarf the entire history of life on Earth. If you place a human life next to these spans, it seems brief. A single lifetime is like a flicker compared with the slow breathing of stars and galaxies. Even all of written history, from the first records carved in stone to the present, occupies only a thin layer near the end of a very long timeline. It can be unsettling to realize how small a fraction of cosmic time is filled by the years you know directly. The mind reaches out to find its place in that timeline and quickly encounters the edge of what it can comfortably imagine. Yet brevity does not mean insignificance. Many processes in the universe happen so slowly that, during a human life, they might as well be fixed. The sun's brightness changes only slightly over centuries. The shapes of constellations shift so gradually that you would need many generations to notice the difference. The orbit of the solar system around the galactic center takes hundreds of millions of years to complete, so during all of recorded history, it has traced only a tiny arc. On the scale of your days and years, these large motions form a quiet, stable background. This stability allows human lives to unfold with a sense of continuity. The sky you see tonight is very similar to the sky seen by people who lived thousands of years ago. The same planets wander against the same patterns of stars. The same Milky Way arches faintly overhead on clear nights. Even though the universe is changing on large scales, those changes do not disrupt the local conditions that support your daily existence. You are brief in comparison with the universe, but you live within a frame that is gentle and steady on human timescales. Thinking about mortality in this context can lead to different feelings. One reaction is to focus on smallness, to sense that a short life in a large universe might not matter. Another reaction is to see that the very brevity of a life can give weight to what happens within it. Because your time is limited, the choices you make and the experiences you have cannot be repeated endlessly. They gain meaning from the fact that they occur within a short, clearly bounded span set against a much longer backdrop. The long universe does not demand that you match its length. It does not require you to think in billions of years or to carry the full scale of cosmic history in your thoughts. It simply continues, providing a stage that remains stable enough for many brief, overlapping lives to play out. Your awareness touches only a small slice of that stage, both in space and time. Within that slice you can form connections, learn, create, and rest. As you consider this, you might imagine your own life as a short line drawn across a vast page. The page is the history of the universe. Most of it remains blank to you, not because nothing happens there, but because it lies beyond your direct experience. Your line is small, but it is also precise. It marks a real period during which you are able to think about these things at all. The feeling that space and time are vast arises from comparing that line to the whole page. The comfort can arise from realizing that your task is not to cover the page, only to inhabit your own line as fully and gently as you can, while the larger universe continues its slow, quiet changes around you. At some point in thinking about the universe, you reach a limit where pictures no longer sharpen. You may try to imagine the full extent of the cosmic web, or the detailed structure of a galaxy, or the precise way space expands, and instead of a clear scene you find only a faint, shifting impression. The harder you push, the more the images blur. This is not a sign that you are failing. It is a boundary that almost every human mind encounters when it tries to hold too much scale and complexity at once. Even people who devote their lives to studying the cosmos live with this boundary. Astronomers and physicists rely on equations, simulations, and carefully simplified diagrams to handle ideas that cannot fit into a single mental picture. They may understand the relationships between quantities very precisely, but when they close their eyes, they do not see the exact universe their calculations describe. Instead, they see models, slices, and hints. They move back and forth between detailed mathematics and rough visualizations, knowing that each way of thinking captures only part of the whole. Your own mind uses similar strategies on a smaller scale. You might hold one or two clear images at a time, such as a spiral galaxy or a cluster of bright stars. Around those images lies a softer region of understanding, where you know certain things are true without seeing them vividly. You know that galaxies gather along filaments, that space can expand, that background radiation exists, but these ideas may live more as words and feelings than as sharp shapes. This layered understanding, with a focused center and a hazy edge, is a natural way for thought to organize itself. Trouble comes when you expect yourself to see everything clearly at once. You might feel frustrated that you cannot picture the whole observable universe, or that the notion of an expanding space keeps slipping away just when you think you have it. That frustration can make the universe feel hostile, as if it were refusing to cooperate. In reality, the limits lie in your own nervous system, which is tuned for different tasks. It excels at recognizing faces, reading expressions, navigating rooms, and following stories. It is not designed to hold a complete model of billions of galaxies in one act of imagination. Making peace with what you cannot picture begins with accepting this design. Instead of demanding a single perfect image, you can let your understanding consist of several partial ones. You might picture a galaxy when you need to think about stars, a filament when you need to think about large-scale structure, and a simple stretching surface when you need to think about expansion. You can switch between them as needed, knowing that none is complete, but that together they carry the main ideas. You can also allow some knowledge to remain purely verbal. You may remember that there is a cosmic horizon without seeing its exact shape, or that background radiation exists without picturing its detailed pattern. These facts can sit quietly as statements you trust because they are supported by evidence and careful work, even if your mind does not turn them into vivid scenes. Not every part of understanding needs to be visual. Language, logic, and a sense of coherence can support your grasp of the universe alongside images. As you loosen your grip on the need for perfect pictures, your thoughts can become calmer. The universe remains as large and complex as before, but your relationship with it changes. Instead of trying to carry all of it in your head, you allow yourself to touch it in small, manageable ways. A single idea, like the time light takes to reach you from the sun, can stand in for a much larger structure. A single image, like a spiral arm or a faint band of the Milky Way, can represent a vast system. In this softer approach, the edge of what you can imagine is no longer a sharp barrier. It becomes a gradual fade into mystery. You walk your thoughts out as far as they can comfortably go, then let them rest there, looking out over what remains unknown. The feeling that space is vast is still present, but it is no longer a challenge to be conquered. It is a landscape that can remain partly unseen without losing its beauty. You are allowed to say, "I know some of the outlines, and that is enough for now." With this acceptance, you can return more easily to your own immediate world. The room around you, the weight of your body, the quiet sounds nearby, all lie well within the range of what you can picture and understand. Beyond them, the universe continues to unfold in ways you only partly grasp, and that partial grasp is entirely appropriate. You are a finite mind in an infinite setting, and peace comes not from forcing the setting to shrink, but from allowing your understanding to have edges and letting those edges be gentle. There is a way to think about the universe that turns its size from something sharp into something soft. Instead of treating the vastness of space as a puzzle you must solve or a challenge you must meet, you can let it become a background, a quiet setting behind the small circle of your daily life. The galaxies, clusters, and filaments are still there, stretched across distances that language can barely describe, but they no longer stand in the foreground of your attention. They become like a distant landscape, always present, rarely urgent. Imagine the night sky in this gentler role. You are not standing beneath it to perfect your knowledge or to test your limits. You are simply aware that above your ceiling, beyond the roof, past the air and the thin shell of atmosphere, there is a wide, dark space filled with stars. Those stars move on timescales so long that, for you, their patterns are effectively fixed. The constellations change slowly, but not in a way that will disturb your sleep or alter the shape of tomorrow. The universe is active, yet on human timescales it behaves like a steady backdrop rather than a restless crowd. This steadiness can be reassuring. Many of the things that trouble you belong to small, close layers of experience. A difficult conversation, a long task, an uncertain decision. These all happen within a narrow band of space and time. They may feel enormous from the inside, but when you compare them to the age and size of the universe, their scale shrinks. The point is not to dismiss them, but to acknowledge that they exist within a much larger frame that remains calm. While you lie still, the Earth continues its path around the Sun continues its path around the galaxy, and the galaxy continues its place within the cosmic web, all without needing your attention. If you wish, you can picture this background as a very distant shoreline. On that shore stand galaxies and clusters, like faint lights along a far horizon. Between you and that horizon lie layers of space that you will never cross, but their presence is enough. They remind you that you are not at the center of everything, and that the universe does not hinge on your thoughts. For some people, this can feel like a loss of importance. For others, it is a release, a sense that they are free to rest, because the larger structures do not require their effort to continue. At night, as you prepare to sleep, you can let this perspective settle softly around you. Your room becomes a small, clearly bounded space where everything is within reach. Outside that room is a building, a street, perhaps some trees or other houses. Outside those lie wider landscapes, coastlines, mountains, or plains. Beyond them is the curve of Earth, the orbit of the Moon, the path of the planets, and so on, in widening circles. Each circle is larger than the last, yet all of them coexist without pressing in on you. You occupy one small circle, and the others stay where they are. Your breathing can reflect this layering. With each slow inhale, you take in air from the thin shell around the planet, an immediate gift from your nearby environment. With each slow exhale, you release that air back into the same layer. The exchange happens close to you, within a tiny fraction of the universe, and that tiny fraction is all you need. The rest of space can remain distant, vast, and undisturbed. If thoughts about the size of the universe appear while you lie there, you do not have to chase them. You can let them drift like faint clouds on the edge of awareness. You know that far above you there are stars and galaxies whose light has traveled great distances to reach this planet. You also know that you do not have to hold those distances precisely in your mind. It is enough to feel that they are large, stable, and far away. The universe keeps its own pace. You are allowed to keep yours. In this way, vastness becomes a kind of quiet reassurance. The same immensity that once seemed overwhelming can now feel like a wide, steady frame around a much smaller, gentler scene. Within that scene, your body rests, your thoughts slow, and your eyes grow heavy. The universe remains what it is, far beyond the walls of your room, and that very distance gives you space to let go, to loosen your attention, and to move gradually towards sleep. If you lie quietly and let your thoughts move outward, you can trace a gentle path from the smallest details of your own body to the widest structures of the universe. You begin with the weight of your limbs, the rise and fall of your chest, the steady rhythm of your heartbeat. These are scales you know intimately, measured in centimeters, seconds, and breaths. They anchor you in a place and a moment that are entirely your own. From there, your awareness can expand to the room around you. Walls, furniture, floor, and ceiling form a familiar shape. You know where the door is, where the light comes from, how far it is from one corner to another. The distances inside this space are small enough that you could cross them in a few steps. They are held inside your memory and your muscles. Even with your eyes closed, you could reach out and touch a surface exactly where you expect it to be. Beyond the room lies the larger structure of your home, your street, your neighborhood. These are patterns of paths and buildings that you navigate without thinking about their relation to stars or galaxies. They feel complete on their own scale. You move through them during the day, making choices, meeting people, solving problems that belong entirely to this human layer of reality. Streets and rooms may not be cosmic, but they are real, and they are where your life is lived. Far above these familiar spaces, Earth turns steadily. The planet carries oceans, continents, and atmosphere through the darkness, rotating and orbiting without pause. On this scale, your room is a tiny patch on a vast surface. You are part of a thin layer of air and water where life can thrive. Above that layer, the atmosphere thins into space. Beyond it, the moon circles, the planets follow their paths, and the sun holds everything close with its gravity and light. Wider still, the sun is one star among many in the Milky Way. The galaxy stretches out as a broad disk, filled with hundreds of billions of stars, clouds of gas, and traces of dark matter. The solar system is a small region within one arm of this structure, circling the galactic center on a path so long that it spans hundreds of millions of years. The galaxy itself drifts within a local family of galaxies, and together these systems lie along strands of the cosmic web, surrounded by great voids where very little matter has gathered. At each step outward, the numbers grow larger and the images grow softer. Distances reach beyond simple pictures. Timescales extend beyond any individual memory. Yet the path from your heartbeat to the cosmic web is continuous. There is no break between the world you touch with your hands and the universe traced out by telescopes and instruments. One flows into the other through layers of scale and understanding. You are not separate from the cosmos. You are one of the forms it takes at this particular place and time. You do not need to hold all of these layers in focus. It is enough to know that they exist. The small circle of your immediate experience rests inside larger circles that are stable on human timescales. While you sleep, the Earth will keep turning, the planets will keep orbiting, and the stars will keep shining. The expansion of space, the glow of distant backgrounds, and the slow evolution of galaxies will continue in a way that asks nothing of you. The universe carries its own history forward. You are free to let go of it for a while. As you allow your thoughts to drift, you can let the largest scales fade into a gentle awareness that space is wide, old, and calm. Your attention can return to the feeling of the surface beneath you, the softness of fabric against your skin, the quiet of the air around you. You are a small mind resting in a large universe, and the size of that universe does not need to be solved tonight. It can remain vast and partly unknown, while you become smaller and more still inside your own familiar shape. In that stillness, the distance between galaxies becomes a distant fact, no heavier than a thought. The weight of your body, the slow rhythm of your breath, and the safety of your immediate surroundings become the things that matter. Above you is a sky that has held its patterns for countless generations. Beneath you is a planet that has carried life for a very long time. Between them is a quiet night in which you can finally rest. We from Sleepy Stories wish you a good night.